Patty Simpson with Simpson Math. Let's create a frequency table with quantitative data. So we have data here that was collected on the number of miles professors drive to work daily. And the data is shown here below. And we want to create a frequency display, a frequency table that shows the frequency in each of our categories. But the first thing we need to do is decide on how many categories we want and what those categories are going to be. Now, I'm going to provide the number of categories or classes or bins for you. And here I say to use 6 classes. There are lots of different techniques for finding the number of classes, but many of them involve some upper level math. So I'm just going to tell you that we're going to use 6 classes or bins. So then the next thing we have to do is figure out how wide our classes or bins are going to be, or what the minimum width is. So the way we do that is the first thing we do is find the range of our data. And the range of our data is just our maximum number minus our minimum number. So we look for the largest number in our data set, and the largest number in our data set is 11.8. Then I'm going to look for my smallest number in my data set. And the smallest number in my data set looks to be 1. So when I subtract those, I see that my range is 10.8, or 10 8/10. I'm going to take that range now, how spread out my data is, and I'm going to divide it into 6 equal groups, and I want to know how much is going to be in each group. How wide is each one of those groups going to be? So our width, and actually this is our minimum width, it's the smallest that we can make each of our classes or bins. We're going to take that 10 8/10, our range, and we're going to divide it by the number of classes or bins we're going to use. In this case, 6. So 6 goes into 10 one time with 4 left over. 6 goes into 48 8 times. So 6 goes into 10 8/10, 1 8/10 time. This is the smallest that we can count by, the smallest that our classes can be wide. And actually we need to round that up 1 spot. So we round that up to at least 1.9. We need to count by at least 1 9/10. Now, I don't want to count by 1 9/10. That just seems like an awkward number to count by. It might be easier just to count by 2s. 2s are a nice, pretty number that's bigger than 1 9/10, and yet it's close to that, and it's a reasonable number to count by. So I'm going to make my width of my classes 2. Then I just need to decide on what those classes will be. Well, I need to make sure that I start at a spot where I can include my minimum number. So maybe my first one, I start at 0, because between 0 and 2, 1 would fit in there. So I'm going to start my first class. So here I'm going to put my categories. These categories are the miles that the professors are driving. So my first category is at 0. I'm going to count by 2s now. 0, 2, 4, 6, 1, 2, 3, 4, 5, 6 classes. 0, 2, 4, 6, 8, 10, and that gives me 6 categories. Now I need a stopping spot as well. That's my starting spot. My stopping spot needs to stop before 2. And since I count by tenths here, I'm going to go out to that tenths. So 1 9/10 would take me to that next number. I'm going to do the same thing where I count by 2s, because I've decided my width is 2. So I'm going to count by 2s. Well, 1 9/10, count by 2s, and I'm at 3 9/10. This is 5 9/10, 7 9/10, 9 9/10, and 11 9/10. So I've created my 6 categories, or my 6 classes, and I'm going to make sure that my minimum and my maximum all fall in there. Well, my minimum number was 1. It falls in the first bin. And my maximum number was 11.8. That falls in the last category. So every data point has a place. Every data point has a class or a bin that it belongs in. Now, I'm just going to count the frequency of each. So in other words, how many data points are in, how many professors drive those many miles to work every day. So this part is the number of professors. So professors. So how many professors drive between 0 and 1 9/10 miles to work every day? We go back and look at our data, find out, and it looks like there's only 1 professor that drives that distance to work each day. Then between 2 and 3 nights, so here's 1, 2, 3, that's it. 3 professors drive between 2 and 4 miles to work every day. Then between 4 and 5 nights, we just count how many data values there are. So there's 1, 2, 3, 4 professors that drive that distance to work every day. Between 6 and 7 nights, so 1, 2, 3, 4 professors drive that distance to work every day. 8 and 9/10, between 8 miles and 9/10, so 1, 2, 3 professors that drive that distance, and then last but not least, this more than 10 miles there, from 10 to 12 miles there is 1, 2, 3 professors that drive that distance each day. I'm going to kind of check myself just by making sure that I have enough data values. So there's 4 and 4 makes 8, 12, 13, 14, 15, 16, 17, 18. I have 18 professors represented there. And let's see how many data values I had. Well, it was 3 times 6, so there's a total of 18 data values. So I at least have given every data value a home. With frequency tables, as well as with any other display, we need to make sure that we have a title. So for this one, my title is just something that lets my reader know at a glance what my data is. In this case, it's the miles professors drive. Just some title to let your reader know what it is your data represents. So there's a frequency table of this quantitative data. Math Made Simple at Simpson Math. Thanks for watching.